Okay, grade 7. This is chapter 11, lesson 4. Compare populations. Okay? And like I told you, we must know how to read, we must know how to label, we must know how to solve correctly, we must know how to use vocabulary correctly, we must know what the words we are reading, what do they mean, how do I get them, okay? So, let's begin. This picture you're seeing over here is called a box plot. It's called a box plot, just like it says over there. Okay, so it says box plot. Sometimes it's called box and whisker. Box and whisker. Box and whisker plot. Okay. All right. So, let's read this question. So we will start with a real world link. So there is a Mr. Amar, yes? And Mr. Amar had students in his first period. And when the students came to his first period, he surveyed them. He created a survey. He wanted to know how many times do the students exercise in a month, whatever month that was, whether it was January, February, it doesn't matter. Whatever month he conducted the survey, he wanted to know how many times did the students in this class, who are in his first period, exercised, okay? And this is the data he got. And he presented his data in a box plot, okay? Now, from the box plot, we should be able to read the data. So, I drew mine over here, just to explain to you closely. The first dot represents the minimum, the smallest value in your data set. The second dot represents your lower quartile, or Q1, or first quartile. Q1 has three names: lower quartile, first quartile, or Q1. The second dot represents the median. Sometimes the median is called Q2. Okay, so you have Q1, Q2, Q3. I can't see this dot. I have to make it darker. Okay, there are three dots that make the box. So this is the box and this is the whisker. Okay, this line over here from Q1 to minimum and this line from Q3 to maximum is what we call the whisker. W-H-I-S-K-E-R, whisker. So this is the box and whisker plot. Okay, over here too, this line is called the whisker. Okay, all right. And then the last dot is your maximum, which is the largest value. Q3 also has different names: upper quartile or third quartile. So from your box and whisker plot or from your box plot, you should be able to get how many values? 1, 2, 3, 4, 5. And these 5 values is what we call the 5-number summary. The 5-number summary. So, I get a 5-number summary from a box plot. What is the 5-number summary I should get? I should know the minimum. I should know Q1. I should know the median. I should know Q3. And I should know the maximum. That's what the 5-number summary represents. Okay? Now, according to our picture, our minimum is 0. So I will write 0 over here. I will write 0 there. What is my maximum? The largest value, which is 30. I will write 30 here. What is my first quartile? My first quartile is 5. I will write it over there. My third quartile is 20. How do I get my range? I do 30 minus 0. 30 minus 0, which gives me 30. And what do I do here? To get the interquartile range, I do 20 minus 5, which gives me 15. And there, I have answered my 5-number summary. Actually, this is not my 5-number sum because it doesn't give me the median. Yes. But I have answered the question that I was asked. Okay? Now, question 2 asks me, what is the median? The median of my data is right here, which is 10. The median is 10. What does the median represent? We need to answer that question. What conclusion can you make from the box plot? Okay? Now let's come here and let's do our vocabulary. The minimum, the least value in your data set. What is the least value in our data set? 0. That's why I said here the answer is 0. What is the maximum? The greatest value in the data set. What is the greatest value in our picture? Our greatest value is the maximum, which is 30. How do I find the range? I find the range when I subtract the maximum and the minimum. The range is the difference between the greatest value and the least value. So here it is 30 minus 0, which is 30. The first quartile, or Q1, or lower quartile. Here, what is our, I didn't write the answer. Here it is, what is our lower quartile? 5. Here it is 5. Okay. It is the median value of the lower half of your data. It is the middle of the minimum and the median. You go to the median and the minimum, the dot that is there between, that is your Q1. Okay? We will see how to make this when we have data. Okay? You will see just now. All right. Here, the third quartile is Q3, or it is called the upper quartile. So when I say third quartile, I mean Q3 and I mean upper quartile. These are the names. These names are the same. So it is the median value of the upper half of your data. It is the middle of the median and the maximum. So the median and the maximum, the middle value is Q3. And in this question, it is what? It is 20. Here it is 20, according to this data. Okay? All right, interquartile range. It's referred to as IQR. How do I do IQR? The difference between the third quartile and the first quartile. That means third quartile minus first quartile. Third quartile is 20. First quartile is 5. 20 minus 5 is 15. Okay? There you go. Here, maximum minus minimum for the range. So make sure you put maximum minus minimum equals range. Okay? The median, the middle value of your data set. Here, it is 10. Now let us answer, what does the median represent? We are answering this part of the question. What does the median represent? The median represents half of the students exercised fewer than 10 times. When you're using the word median, you must use the word half. Okay? When you're explaining median, you must use the word half. So you're saying half of the students who came to Mr. Amar's class exercised fewer than 10 times, or half of the students exercised more than 10 times. So you will write two sentences, one to describe the lower half and the other one to describe the upper half. So when you go to the left of your median, you say fewer than. When you go to the right, you say more than. Because the numbers on the left are less than, and the numbers on the right are more than, are greater than. So that is why we said half of the students exercised fewer than or less than. It doesn't matter which one you use. You can use fewer than or you can use less than. Less than 10 times during the month, and half of the students exercised more than 10 times during the month. Keywords: fewer, more than. Very important, okay? Very important. Now, they asked us to make conclusions from the box plot. If you look at my box plot, you can see I wrote these percents. The box plot is divided into 4 equal parts. The first quartile is 20. It's called a quarter because we are dividing into 4 parts. So the first quartile is represented by 25%, or the fraction 1/4. Okay? This is also 1/4 of your data. This is also 1/4 of your data. And this is also 1/4 of your data. So 1/4, 1/4, 1/4, if you add them, you get 4/4, which is your whole data. Okay? So the data is divided, the box plot is divided into 4 parts. Each part represents 25%. So these percents are what we are going to use to make the conclusion from our picture, our box plot. Okay? So we will write 25% of the students exercise between 0 and 5. Between 0 to 5 times, 0 to 5 times. So you pick the spaces between your dots. Okay? Like that. 25% of the students exercise between 5 to 10 times. 25% of the students exercise between 10 to 20 times. So you see? 10 to 20 and 20 to 30. 25% of the students exercise between 20 to 30 times. Or you can use the fraction. If you don't want to use percent, you write a quarter, a quarter, a quarter, a quarter. Make sure you write nicely. Remember, when you're making conclusions from a box plot, these are the only numbers you should use. You can't use any other numbers for percent or fraction. You must use 25%, or you must use 1/4. You cannot use any other number. This is what you should start with. These ones depend on the number on your box plot. Okay? Times. It depends what your box plot is representing. But you must start with 25 and a quarter or a quarter. You can't write both. You either write 25% or you write a quarter. Okay? Now, what's the next part? We need to know how to determine whether my data is symmetric or non-symmetric. This you must know. So here, I have drawn pictures to help you. So this is a box plot. And this is a dot plot. Box and dot, box plot and dot plot. Now, how do you determine your box plot or your data plot is symmetric the left of the data looks exactly, sorry, the left half of the data looks exactly as the right half of the data. Exactly. That means the left is equal to the right. So here is the middle of my data. This side is equal to this side. Then my data is symmetric. You see? Here is the middle of the data. This side is equal to this side. So then my data is symmetric. If you look over here, this side is bigger than this side. So then it is non-symmetric. Look, they don't look the same. If this is where my half of the data is, this side does not look the same as that side. Okay? So, why is this data symmetric? Because the left half of the data looks exactly as the right half of the data. Why is this data non-symmetric? The left half of the data does not look exactly as the right half of the data. Now, when your data is symmetric, the center you will use is the mean to describe your data. When you're describing data that is symmetric, you must use the center mean and you must use the variation mean absolute deviation. When your data is non-symmetric, the center that you will use is the median and the variation is the interquartile range. Okay? Do not confuse that. This is very important. Non-symmetric, you use median and interquartile range. Symmetric, you use mean and mean absolute deviation. Now let us see how to do mean absolute deviation. So I use this data set. I got my data from my data plot, from my dot plot. How many 10s? 1. How many 20s? 2. Because there's 2 dots of 20. How many 30s? 3. 3 dots of 30. How many 40s? 1, 2, 3, 4, 5. Because I have 5 dots, like that. 53 of them, 62, and that. And then I found my mean. I added all these numbers in the data set, and I got 680. And how many numbers do I have? I have 17 of them. I divided and I found my mean. After I found my mean, I need to subtract the mean from each data value and find its absolute value. Okay? So you first find the mean, then you get this answer over here and use it by subtracting from each of the numbers and then find the absolute value. And that's what I did over here. So I did 10 minus 40 like that for all my data set. And then I found the absolute values. Remember we learned absolute value in term 1. Absolute value, because we don't want negative numbers. Since we have a negative answer here, we must only use positive. So that's why we are doing the absolute. And the question also said find the mean absolute. So for you to find the mean absolute, you must find the absolute value. So the absolute value of negative 30 is 30. You do all this for all your data. You see? And then step 3, add all your absolute values and divide by how many values you added. So I added all these. I got 200 and I divided by 17. So my mean absolute deviation is 11.76. Depending on the question, if they ask you to round it to the nearest tenth, then you round it to the nearest tenth. Okay? The question tells you how to round. So, this is how you find the mean absolute deviation. Okay. After you find the mean absolute deviation, I want to show you how to find interquartile range. Okay? So, I will do the interquartile range 2 ways. Okay? So, you've been given a data set. This is your data set. And you want to find the interquartile range. So, you have all this data set. First, find the median of your whole data set. Everybody. So, I arranged, I crossed out 12 with 27, 15 with 23, like that. And then I was left with two numbers in the middle. Because I was left with two numbers in the middle, I put a line here. And this line is what is going to help me find my lower quartile and my upper quartile. So the left of this line is the lower half. And the right of this line is the upper half. Okay? So I found my median. I added 18 and 19. And I divided by 2. And this is my median. Okay? Now, I want to find the interquartile range. The interquartile range needs the lower quartile and the upper quartile. So how do I find the lower quartile? I go to the lower half, which is this part. The lower half is this part. Okay? And the upper half is this part. Alright. So I took the numbers that are on the lower half, which are 12, 15, 15, 16, 17, 18, 18, and 18. And then I found the median. I crossed 12 with 18, 15 with 18, 15 with 18. I was left with 16 and 17. So what will I do? I will add, divide by 2. I got 33 over 2, and I got 16.5. I did the same with the upper half. I arranged 19, 19, 19, 20, 22, 22, 23, 27. I crossed my values. I was left with two numbers in the middle. 20 plus 22, I got 21. But the question told me find the interquartile range. So the IQR is Q3 minus Q1. What is my Q3? 21. What is my Q1? 16.5. I subtract, and this is my answer. Okay? Let us look for it in a different data set. In this data set, okay, I arranged my data from least to greatest. Remember, you have to arrange your data from least to greatest. And then you cross and you find your median. So my median here was 70. This is my median. I drew a circle because it was only one number. So that's my median. Then I go to the left of my circle and take all the numbers on the left. And go to the right of my circle and go to all the numbers on the right. The numbers of the left of my circle is the lower half. The numbers on the right of my circle is the upper half. And then I find the median of my lower half. The median of my lower half is the first quartile. Okay? So I cross. Remember, you should cross the same numbers, the same amount of numbers on the left and the same amount of numbers on the right. I was left with two numbers. I add, I divided by 2. That's Q1. I did the same on the other side, and I got my Q3. Okay? The same thing. And then my interquartile range, Q3 minus Q1, 80 minus 45. And that's how to find the interquartile range. You now know how to do symmetric data. You know now how to find non-symmetric data. You know how to find the interquartile range. You know how to find the mean. You know how to find the median. You know how to find the mean absolute deviation. Okay? This information is what you need from this for this lesson. If you don't know how to do this part, then there is no way you're going to be correct. You know how to make conclusions from a box plot. You know how to find your mean. You know how to find your 5-number summary. Okay? This is very important for you to be successful in this lesson. Now, we will do part 2. So do that first. This is part 1 of your video.